So cycle notation for permutations. So you get this idea that you can compose several, but within each permutation, you can look at cycles, you can look at pairing within. Huh? Well, what we're looking at with a permutation like this is that when we do a 1, 2, 3, 4, and then we have 3, 1, 4, 2, the way these are paired, you could within itself, 1 could go to 3, then 3 could go to 4, and then 4 could go to 2, and then where does 2 go to? Back to 1. This would be a complete cycle of 4. So 1 goes to 3. We said 1 to 3. Then 3 to 4. 4 to 2. 2 to 1. You don't write the 1 again. You leave it at that. 1, 3, 4, 2. Now, you could have started with 3, 3, 4, 2, 1. But we usually put the 1 first. So what would happen is if you had 3, 4, 2, 1, you would just put the 1 first, then you would have 3, then you'd have 4, and then you'd have 2. Does that make sense? You just want the 1 to be first. Let's see. Now, sometimes weird things happen, unfortunate things, like this one. 1, 2, 3, 4, 5, 4, 3, 2, 5, 1. Now you go 1 to 4, 4 to 5, 5 to 1, and then it would just keep repeating, right? And it would leave these two out. So we would call this a disjoint cycle. 1 goes to 4, 4 goes to 5. And then there'd be another disjointed cycle within 2, 3, 3, 2. How'd you get that? We're going to look at that today. Yeah, Tommy? Hang in there, hang in there. Now we could look at another one. Maybe this is what Tommy was going to ask, is what if just 1 goes to 1? That's a cycle all by itself. It's a lonely cycle. 1 is the loneliest cycle, yeah, that you'll ever do. 3 is also a lonely cycle. And then how about 2? Well, 2 can go to 4. 4 goes to 5. 5 goes back to 2. So we have 2, 4, 5. And then this 3 again is all by itself. Normally what they do, and it's a little confusing to me why they do it, but it's just the way it is, they don't include these. They leave the single, it's only 1, so we just ignore them. Anybody who's alone, we just ignore. Like at restaurants? Yeah, it's terrible. Yeah, it's just the way it is. All right, so a cycle has R elements, and they'll have each a length R, but there can be as many disjointed cycles as there are. There could be no disjointed cycles, there could be a whole bunch of them. They could all be disjointed cycles. If they're all disjointed cycles, what do you think that is? What do you think we call that? That's the E. Yeah. Yeah. So that's the identity. What would it look like as far as a permutation? Well, it's the one you're familiar with, right? So that's really the connection here. This is the permutation. This is the cycle. So you could have R elements and R cycles, all disjoint, and then they'd be E. Every cycle is a permutation, but not every permutation is a cycle, like this one. All right. So how does cycle notation tell us about permutation composition? This is where it gets ugly. I did so poorly with this last hour, but it's going to go better this time. Every permutation can be written as a composition of disjoint cycles. So your S of n can be, permutation can be written as into a series of disjoint cycles. So what I think would be helpful is we're going to write this Q as a permutation. Permutation is going to be 1 goes to 4. Oh, it does go to 5. 1 goes to 4. 4 goes to 5. Right? What does 5 go to? 1. Yep. And then it says 2, 3. So 2 must go to 3, and 3 must go to 2. So there's your Q. Now, R is interesting. 1, 2, 3, 4, 5. R says that 2 goes to 4, 4 goes to 5, and 5 goes to what? To 2. Well, then what must happen with 1 and 3? They go to themselves. Yep, so there you got it. Now, here's what we're going to do. We're going to do QR. QR, so the outside is 1, 2, 3, 4, 5. 4, 3, 2, 5, 1. The inside is 1, 2, 3, 4, 5. 1, 4, 3, 5, 2. And we're going to combine these. So let's see if we can do this. 1, 2, this is QR. 1, 2, 3, 4, 5. This is going to be 1 goes to 1, right? Then 1 goes to what? 1 goes to 1, 1 goes to 4. Yep. 2 goes to 4, 4 goes to 5, 3 goes to 3, 3 goes to 2, 4 goes to 5, 5 goes to 1, and then 5 goes to 2, 2 goes to 3, and it finishes that off nicely. If we write this as a cycle, it's going to go 1, 4, what? 1, 4, 4, 1 again. So this is just going to be 1, 4 as a cycle. Doing okay? And then it's going to go 2, 5, 3, 2. 2, 5, 3, and 2. So that's what my result cycle should be. Okay, now what we're going to do, got to brace myself here, QR. We're going to take, here's Q and here's R. R is the inside, 2, 4, 5. Q is the outside, 1, 4, 5, 2, and 3. So that crowded that in. I don't like that. So it's just 1, 4, 5, 2, 3. Let's use another color here. 2, 4, 5. Here's what I want you to do. See if you can come up with a method for getting this answer with the cycle. So what we did is we explained the cycle idea in terms of moving one cycle within, like 1 to 4, and then if you skip to the other one, 4 goes to 5, you don't write that in your cycle. 4 goes to, if you go 1, 4 goes to 5, and then 5 goes to 2, what happens is that those are going to, compositions aren't written in it. Only the times that you move within do you write them down. And so that's where we get the combinations that you see here, which would be, when you put those together, it's going to be 1, 4, 1, 4, 2, I think it's 3, 5. 1, 4, 2, 5, 3. Yeah. So take a look at the example, and then we work in groups here to look at the theorems, and then you're going to be able to work on the problems that are assigned at the end.